Dialogue understanding is another very important component of an assistant built with Calm. It enables your assistant to understand user inputs and how they want to progress the conversation further. In this episode, we are going to dive deeper into the dialogue understanding component. We will talk about what it is, how it works, and what configuration options you have. When you start building your assistant with Calm, you will quickly notice that the way dialogue understanding component works is very different from traditional NLU-based systems. While the NLU-based approach simplifies the task of understanding user inputs, it makes it very difficult to scale assistants built using such systems. First, it requires big amounts of training data to train the classification models and dialogue management components. On top of that, it becomes increasingly more difficult to introduce new intents because they are too similar to existing ones. Dialogue understanding with Calm takes a very different intentless approach. Instead of interpreting every message in isolation and predicting intents and entities, your assistant will approach the problem from the generative perspective. It produces a set of commands that your assistant should run in order to effectively progress the conversation further. And it does it in a very elegant way, by keeping the conversation natural and getting the user closer to their initial goal. The component responsible for dialogue understanding with Calm is called Command Generator. It aims to represent how the user wants to progress the conversation to achieve their goal. At the moment, there are two command generators available, LLM Command Generator and NLU Command Adapter. LLM Command Generator leverages large language models to interpret the user inputs. For that reason, this command generator needs access to an LLM API of your choice. The beauty of Calm and everything else developed by Rasa is that you can customize the vast majority of the components to fit the needs of your project. You can use any OpenAI model that supports the chat endpoint, such as GPT-3 Turbo or GPT-4 and others. You can configure LLM Command Generator in your config.yaml file as follows. LLM Command Generator works in a way that it takes user inputs and produces a set of commands that represent how the user wants to progress the conversation. In some cases, the right command might be starting a specific flow, like in the example here, where the user would like to make a money transfer. In other cases, it might be setting a specific slot. For example, here, when the user is confirming that they want to make the transaction. Or it might be a set of commands. For example, setting a slot and starting a flow. Just like in the example shown here, where the user would like to send $100 and they would like to see their account balance. As a result, an assistant will set a slot, amount of money, with a value of 100 and start a flow, check balance. LLM-based dialogue understanding components are significantly superior than traditional NLU-based systems in the situations where the conversation can have a lot of ambiguity or where assistant might need a lot of clarifications from the user. For example, let's say the user is interacting with a banking assistant, and the user starts the conversation with a single word, card. For a traditional NLU-based system, it would be really difficult to classify this input and assign any kind of intent to this message because it's very unclear what the user actually wants to achieve. For an LLM-based system, it is easy to simply proceed with asking for the clarification and asking if the user would like to freeze the card, unfreeze the card, or cancel the card, or do something else. And then, when the clarification is provided, an assistant is good to go and proceed with a specific flow. Under the hood, dialogue understanding component has to render a prompt, which is then used to produce the output with the commands. It uses a template consisting of static components and dynamic components filled using the following details to generate a prompt. Current state of the conversation. This part of the template captures the ongoing dialogue. defined flows and slots. This part of the template provides the context and the structure for the conversation. It outlines the main theme, guiding the model's understanding of the conversation's purpose. Active flow and slots. Active elements within the conversation that require the model's attention. Business logic, implemented as flows, plays a vital role in the performance of your assistant. Flows, and more specifically their descriptions, are used by the dialogue understanding component to decide when to trigger a specific flow. So, if you notice that your assistant starts a specific flow when it shouldn't, or when it behaves in a different way than you would expect, you should always go back and check the descriptions of your flows and tweak them to make sure that they are descriptive and precise. One more note about LLM Command Generator. You can customize the template itself by defining which variable should be used to incorporate dynamic information. For more details on that, see the documentation of Calm. If, for some reason, you don't want to use LLM-based dialogue understanding component in your assistant, you have an alternative. You can use NLU Command Adapter, which is a traditional NLU-based approach to dialogue understanding. It requires a traditional intent classifier to be configured in your assistant's configuration. NLU Command Adapter relies on traditional classification for classifying intents and extracting entities. It then uses the predicted intents and extracted entities to find a flow with a corresponding NLU trigger defined. So when do you use NLU Command Adapter? We recommend to use the NLU Command Adapter in two scenarios. 1. You want to migrate an existing assistant that was built using older implementation of RASA and that relies on NLU and stories and rules, and you want to migrate this assistant to Calm paradigm. Using the NLU Command Adapter will make it easier to migrate the stories to flows. This ensures the desired flow starts given you already have a solid intent classifier in place. Second, you want to minimize the costs by not making an API call to the LLM each time. The NLU Command Adapter does not make any API calls to LLM compared to the LLM Command Generators. Using the NLU Command Adapter saves some costs, but make sure you have a solid intent classifier in place when using NLU Command Adapter. Otherwise, incorrect flows will begin. Another great option is that you can have multiple Command Generator components configured at the same time. So, for example, if you would like to use both NLU Command Adapter and LLM Command Generator for your assistant, you can do that as follows, and simply configure both of them in your config.yaml file. Keep in mind that components are executed one after another. This means that if NLU Command Adapter successfully predicts the start of a specific flow, LLM Command Generator will be skipped. LLM-based dialogue understanding components are such a powerful addition to your assistant that can take the conversational aspect of your assistant to the whole new level. And when paired with business logic, it makes your assistant extremely efficient at fulfilling users' requests. There are a lot of different parameters that you can configure when it comes to dialogue understanding components. That's why I highly recommend you to spend some time going through the documentation of Calm to familiarize yourself with which parameters you can tweak and how. There is still so much that we have to cover about building assistants with Calm. We have to talk about how you can implement custom actions, how you can deploy your assistant in production, and so much more. So I will see you in the next episode.